Just to give you a quick understanding, data center is usually owned by the cloud service provider, whether it is Azure, whether it is AWS or Google Cloud. So they have data centers at several locations all over the world. If you visit their website, like on AWS, you will find that, okay, where all these data centers are located. And these data centers are maybe within a country, there are multiple data center, and within a data center, there are so many stacks of web server, cache, databases, load balancer, everything will be there in that. And these data center is mainly to serve uh, the user request which are closer to it. Like whoever user is trying to access some website. So to serve that user faster, again, the data centers are helpful because if they are located close to user, the request will be provided from that particular data center. So this is what we are going to look at it today. So just to give you an idea, I have just mentioned here a few points. Like in our normal operations, whenever a user located anywhere in Asia or India, that user will send a request myweb.com. Suppose you want to access myweb.com through his client, whether it is mobile or computer. That request will go to DNS. But right now you can see I mentioned DNS as GeoDNS. So what is GeoDNS is, again here I have mentioned that in normal operation are users are GeoDNS routed. In the sense, when users send a request to GeoDNS or DNS, user will get routed to the nearest data center. So this is also known as geo-routed. That is to the closest data center. That means if the user is routed to suppose data center at Asia West, then remaining requests, like it depends on how much percentage of user are routed to Asia West, then accordingly, according to the user location, the other users will be routed to Asia East. So these are all kind of keeping balance between multiple. See, I'm talking about just two data centers, but just imagine in a country there will be multiple data centers located at multiple locations, because as users are increasing day by day, it is necessary for every cloud provider should have data centers at multiple locations. So I'm just, for example, I mentioned here two data centers, but just imagine that there will be uh, hundreds of data centers available in a particular region. Okay, so what exactly GeoDNS is? It's again a DNS service that allows domain names to be resolved to IP address based on user location. So as I mentioned, if user is located close to Asia West region, the GeoDNS will provide public address of, means usually it will provide public address of load balancer, which may be closer to user, and that load balancer will send the request to Asia West. So this is how usually everything works. Like if we type anything at our location, we will be routed to a data center which is closer to our location. Okay. And see, the reason behind having multiple data center is, suppose any data center due to some events like flood or fire or anything else, earthquake, if that data center goes down, all the requests will be immediately routed to other data center, which is again closer, but maybe not closer like Asia West, maybe somewhere, some other location. Maybe Asia West itself have multiple data center. So maybe some other healthy data center will get all those requests. So that is the main purpose, that even though the data center goes down because of any uh, events that is causing the data center to go down, it may be anything. So immediately that request should be served by a proper response. And because of that, that request will be sent to another healthy data center, which is maybe in the same region or maybe it is in a other region. So it will immediately send to that so that user will getting the response. There will be no delay in user response. But again, this takes some time for moving from one data center to another data center. And as I have shown here, a data center also contains all the components like cache, database, web servers, and whichever component that we have learned so far. So all those components will be part of data center. And similarly, for the other data center as well. But there are few challenges along with this data center, like first thing that routing your request to a particular data center. So that is as I mentioned here in challenges, traffic redirection. Once according to user's location, the traffic will be redirected to a particular data center, whichever is closer to the user. But even if in case of uh, these fire kind of events, again, this traffic should be routed to the healthy data center itself. So that is again, it's not so easy, but definitely the system should take care of all these kind of routings. The second challenge is data synchronization. That just imagine that you are located at a particular location and your request is always going to Asia West data center, and something happened to your Asia West data center where you are working with that web server, you are saving your data to your database or maybe to cache, and something happened to that data center. What happened to your data? What happened to your cache or what your other application logic within web server? So that if that data center goes down, all the data will be lost. So in that case, mostly all cloud providers, whether it is AWS, Azure, or GCP, they all provide you data replication, like all the data in the database or all the requests that goes to web server, all those will be replicated to multi-region data centers. So even the data is available in Asia West, it will be replicated immediately. No, that immediately is not in 1 second, but maybe sometime it is immediately maybe in 5 seconds or 10 seconds. That depends on how the replication factor has been decided. But that data is replicated to other regions. So immediately it is available even uh, when user or when the data center goes down, immediately if we can send user to another data center, that data will be available. So sometime there are possibility of losing the data, but that is not maybe very immediate data available. That there are chances, but they try to see that the data is replicated more frequently to multiple region. And there is an option with all cloud providers that whether you want to replicate data to multiple regions. That is a choice that is given. That's another challenge that that data should be replicated to multiple regions so that anything happen to one region, other region can take care of the user request or the user data is not lost. And last thing is test and deployment. This is related to when you are working with multi-region or multiple data center. You have to see to it that whatever work that you are going to do and when you are going to perform, like suppose your website is you initially started and all the data you stored in Asia West database or Asia West web servers. All those we will try to test that in this region our website is working fine or not. But similarly, as data is getting replicated to other data centers, it is you should always see to it that in other region also your website is working fine or not. Whether the data is getting replicated, whether all the application logic is working fine in that region. So that's also another challenge. It's not just testing, but also deploying to other region. The CDN is one thing, is there to serve the static content, but all this workflow is working fine for all the data center throughout different regions. So that also another challenge. Testing and deploying is again another challenge for this framework. Okay. So just quick recap that when user will send request to through client to DNS, that will be a geo DNS. Usually it is a geo DNS. Geo DNS will find out the local load balancer because even load balancer will be multiple load balancer. So maybe there will be a geo load balancer which will send request to local load balancer, and that load balancer will send request to a data center which is closer to your location or closer to user's location, and accordingly it will be served. Okay, and there are CDNs also in between which will serving the static contents. That is what we have seen in the last time. So any question on this? No. Let's quickly recap what we have learned so far in this. See, after this, there are multiple components also. There are messaging queues. There are logging, monitoring of systems, which is a very important factor. But we will look into those later on because there are components which are being used to log. See, logging is all web servers which are serving you may go down. So there are logs, there are some metrics which we need to observe. So that we need to see to it that if any web server is going down, how we get the log, that what is the reason behind a server goes down, that log should be available, it should be stored somewhere. And accordingly, we should able to make some decision, or we should at least try inform. There is something called SRE, Site Reliability Engineer, should get information about, okay, how exactly this server goes down, what exactly happened, what are the logs, what exactly the event triggered that, and accordingly what action we can take. That also been suggested to SRE by the system itself. It is nowadays it is called, along with MLOps or AI. There are multiple things: DevOps, MLOps, and AI Ops. So AI Ops is something that is a new technology which has been used, where artificial intelligence will help you with those logs, with some kind of outcome where SRE will be help with a proper solution. Like if something happens like this, if a particular event trigger, what action an SRE should take. So then SRE will run some script or click some buttons, and the web server will be restored back. So these kind of concepts are there. So these are necessary, like for logging or monitoring is important, so that the system, if it is deteriorating over the period of time, it is failing for some because of some events, it should be handled quickly, and the response and restoration should happen immediately. So that is maybe a particular another field itself. We will try to look into those also, but that's why the logging and monitoring is also one of the important component, which we will look at it later. And messaging queue I mentioned, that is one of the component for a specific application. For example, if you want to keep all the components uh, scale differently, in that sense, the messaging queue has been used, and we will look at it for sure. But let me just go back and see what we have learned so far. So I'll just go to first slide itself. So far we have seen all the system components, and as well as design consideration. So these design consideration, or I'll say core principles, availability, reliability, we are going to look at it in the our later sections. We have seen client server model, and as we have seen, see, this all is actually a system design at scale. What we have seen throughout all this session is how we have scaled our whole system from a single server, from a single user, all the way to serving millions of servers. So this system that we have seen so far is serving now at least millions of users. Okay, but depend on the how many web servers are there. So I've just took one or two web servers, but just imagine that there are hundreds of web servers, there are hundreds of databases, cache, and different components are in place. That's why we are able to serve the millions of users. So we have seen client server model. We have seen how the request goes to web server, and how what kind of response we get, and what kind of request it is. And also we have seen the single point of failure of web server. Then we looked at the database, what kind of databases are. We just separated our database component from web server itself, so that we can scale differently. Like web server can scale independently of database, and even database can independently get scaled. And we also seen what are the different kinds of databases are there, and when we should use SQL and NoSQL database. We have seen how we can scale our servers so that we can serve more and more requests as the user uh, the number of users are increasing. We have seen that more requests are going to come. We put one load balance in between. We have seen some basics of vertical scaling, horizontal scaling, and load balancer. Definitely, these are concepts we need to learn in details later on. But we have seen these concepts, that how we have put web server in auto scaling group, and as well as how database is linked with it. Then we have seen how database replication happening on a very, this is, I'm still saying this is a lower level. This we have not seen the actual system that are working or serving millions of users has multiple databases and database replication happening at every single moment. But we have just seen what exactly replication means, how exactly replication happens. We have seen slave and master databases, and what happens if any one of the database goes off or goes offline, and how the request has been served. We have also seen, okay, the overall architecture, how it looks like at web tier and data tier. Then last session, we have seen cache and CDN. What is the purpose of cache? What is the purpose of CDN? How the request has been responded very quickly with the help of cache, and what exactly is cache, what exactly is CDN, and how it is helping user to serve better. And even this is also a single point of failure. We have seen that it's not just one cache, but there are multiple cache, and there are multiple cache available. Like there are Memcache, Redis. These are all in-memory database that helps us to serve better to user. So we will look at it later on in detail for cache and what are the caching strategies we can use. We have seen this last time and how the overall design looks like after applying the cache and CDN in our design. And this is what the overall picture looks like now. The cache, web server, database are part of a data center. So how the request has been routed to multiple data center. Multiple data center will have multiple web servers, caches, and databases. So this is what the overall design about our system. So I'm just trying to see to it that you all should know all these components and you should know what is the complete workflow. And definitely each and every component we are going to get into details, more details, that what kind of database are there available, what kind of cache are available, what kind of strategy we use to route the request to multiple web servers or multiple databases, choice of databases. So that will definitely look into in details. All right. So that is all for today. Uh, do you have any question?
Actually, I have one question regarding the
Yes.
cache.
Yeah.
So, like there is cache also in our systems that we are using. So is
Yes.
this cache similar or means there are some restrictions on the cache that we use, like size and its
Mhm.
speed? So as there are web servers which gets millions of requests, so is
Right.
the size of cache doesn't matter over there, or cache will be updated more frequently? Because many users will request different things. So that
Yes.
might be case like some user requested a thing and that got stored in cache, and some user after some time will not request about that, and that will be lost very quickly because there are many requests at
Yes. Yes.
particular time.
Yeah. See, first question is about size of cache. The size of cache is depend on your system itself. Like we do whenever we design a system, we do a kind of calculation that what exactly size of cache that we expected, depending on how many number of users we are going to get, how many, what kind of data we are going to store in cache. So that there is some calculation involved in how much cache do we need to store. It depends. It's a kind of approximation that we do. Maybe we get a cache of maybe 3.5 GB of cache is needed. So what we do is we also keep some extra space. Like instead of providing exact 3.5 GB of cache, we will provide a 5 GB of cache or 10 GB of cache. That to see to it that if any peak time, maybe holidays or maybe particular time, maybe there is some uh, kind of cricket match or something that is going on. So in that case, the requests are going to get higher. It will be a kind of peak time where we are getting more requests. So to serve those kind of times, the cache size will be little higher than what is expected. So usually we worked on 80-20 principle, like most of the 20% of the time we get like, or maybe 20% of events, we get more requests and 80% serves the normal uh, purpose. So in that sense, we decide the cache size, and definitely the cache replication will be there. And as you're mentioning that as users are adding more and more requests, the cache may get full. Okay, so that's why I mentioned sometimes we provide more cache than what is expected. And second, there is something called, I think we discussed this yesterday. Sorry, in our last session, is we also have cache eviction policies. Eviction means how we can remove certain items from cache so that we can keep on serving the responses. So what we have discussed is there is something called LRU, least recently used. So whatever recently means we have not used it, a particular data that is uh, recently or very frequently been used, that should get removed from the cache. So that kind of policy that we have to use. It is called eviction policy. It depends on system to system whether you want to remove least recently used, least frequently used, or there is first in, first out. So there are multiple strategies which we are going to discuss when we learn cache in details. But these are being used so that the cache is getting empty frequently. There are two reasons for it. Because cache is full, we try to remove it. And there are other reason is cache should get more recent data or more latest data from database. So that's another thing that we have to keep on removing. There is, when we store any information in cache, whether it is Redis or Memcache, when you add something to that cache, we also provide TTL, time to live, for that particular data. So after maybe 60 minutes, that data will automatically get removed from the cache itself. So that is also a kind of strategy we use. Usually all the cache uh, databases, like in-memory databases like Memcache and Redis, they have this particular it's property available where you can define the time to live in seconds, sometime maybe 3,600 seconds kind of information that you provide. You just like when you provide data of key and value, similarly you can also provide uh, information about TTL, like time to live in seconds, and that will get stored. And once that particular time is over, 3,600 seconds, this data will automatically get removed. And for next request, cache has to take that information back from database itself. Is it clear?
Yes.
And definitely we'll look into these kind of strategies in detail for sure. All right, so I'll stop recording now.